So this is 3.7, comparing objects. And we've already compared different values, whether that be strings or integers or doubles, different data types. But now we're going to specifically talk about objects and when we're going to compare them and how to compare them. So it starts off by saying comparing objects is a little different than comparing primitive typed values like numbers. Objects can be very complex and have many attribute values for instance variables inside of them. For example, we've worked with turtle objects. And turtle objects have many instance variables like name, width, height, the x position, the y position, etc. When comparing two turtle objects, we need a specially written equals method to compare all of these values. In this lesson, we'll take a look at string objects and how they are compared with the double equal sign and then the equals method. All right, we've used the equals method already to compare strings. And it says the equals method for strings compares two strings letter by letter. For example, it gives S1 dot equals S2. Okay, it's going to be true if S1 and S2 both have all the same characters in the same order. Right? It's case sensitive as well. With strings and other objects, you almost always use equals instead of the double equal sign to check their equality. It says when the operator, the double equal sign, is used to compare object variables, it returns true when the two variables refer to the same object. Okay, so if they refer to the same object, then it would return true. These variables are called object references and aliases for the same object. With strings, this happens when one string variable is set to another. Okay, so we're going to get a visual here. We'll look through this. And we are creating an object from the string class, and we're going to call it A. It's going to be a new string, and we're passing in hi. Okay, and the same as B, we're going to go ahead and create another object from the string class. It's going to say bye. And then C, string C, is assigned the value of B. So C is an alias of B here. So, just once again, another visual, you have A. A is assigned the value hi, but B and C, B is the same as C. C is just another way to refer to B. An alias is like a nickname. Okay, so you can use B and C, knowing that C is assigned the value of whatever B is. If you were to change the value of B, okay, C is still assigned to B. If you run the following code, what will be printed? So let's take a look at it. We have our class, we have our main method. Okay, we have S1, which is a string. We pass it the value hello. We also have string 2 and pass it a string and it says bye. And then string 3, S3, is assigned the value of S2. S3 is now an alias for S2. So if I were to print out system.out.println S3, it should print out bye. Now we have system.out.println S2, the double equals to sign S3, and then also system.out.println S2 dot equals S3. So let's take a look at this. We'll run it and then we'll explain the answers. So if you take a look at this, right, the value of S3, it prints out bye. And then notice the S2, the double equals sign, is it the same as S3? That is true. The same as S2 dot equals S3 is also true. Okay, we've passed 1 out of 1 correct 100%. Says the following video traces through the code above and shows how equals and the double equal sign and equals work with string objects in memory. Taking a look here, you know, I can go through and watch this video, but really, if you go through to the end of it, the way that they've written this out, I can't remember if we've watched a similar video to this, or this is just memories from last year I'm thinking of. So really, I guess I'll zoom in here of this picture, right? There's a value inside of S1, and that value is hello. And we have a certain string that attaches to this value. Now notice that S2 and S3 are both attached to by, because S3 does not create entirely separate by. It is referring to, it's an alias of S2, and it refers to by in the same way. It doesn't create an entire new object there. It just refers to it. All right. Well, there you go. There's the picture right there. It says here's a representation of memory where S2 and S3 refer to the same string object. If you use the new keyword to create a string, it will always create a new string object. So even if we create two string objects with new that contain all the same characters in the same order, they will not refer to the same object. Okay, so in this example right here, notice we have S1, it's a new string, and we are passing it the value hello. And then S2, even though we're passing it hello as well, these are not equal, right? Now, when I run this, check this out. One's going to be false and one's going to be true, because S1 is not the same thing as S2. They're not the same. We created two different objects. The equals says, are these two the same thing? And the answer is no. But dot equals said, hey, what the string says is hello, the same as hello. Yes, that is true. So it's something to be aware of and make sure we're using the proper one. If we want to see if the values inside of them are the same, we would use dot equals. But are we saying, are these two objects that we're comparing, is S1 the same as S2? And the answer is no. So even going back to the previous example here, right? S2 was equal to S3 because all we did was create an alias for it. S3 is S2. If I would have written S3 is assigned new string by, okay, this right here, S2 double equal sign S3 would have resulted false instead of true. But we didn't write that out like that. We just assigned it the value, whatever's in S2. Thus why we have this picture here. It doesn't create an entirely separate object. We're both referring to by. All right. And then there's the video. I'm just going to run it for a second. You can watch it if you really want to, but this gives the same exact representation, knowing that S1, even though it says hello, is an entirely different object as S2. Okay, the values inside of them are the same, but they are separate. Note that you can also create strings using string literals instead of new, like string s equals hello. String literals behave a little differently because they are reused if they already exist instead of creating a new object. But you should not see questions with string literals and double equal sign on the AP exam. All right. To note here, it says what we kind of just went over. It says use the double equal sign with primitive types like int, or to test if two strings or objects refer to the same object, and use equals with strings to test if they're equal letter by letter. All right. So here we go. Which of the following is true after the code executes? So I have S1 is assigned hi, a new object. S2 is a new object, it says by. S3 is a new object, and it says hi. And then S2 is assigned S1. All right, so now S2 is a nickname or an alias for S1. We've completely changed the value of S2. So now let's look at our three different options. S1 equals S2 and S1 equals S3. That wouldn't be true because S3 is still an entirely separate object. If this said dot equals, then yes, it would be true, but it doesn't. This one, S1 equals S2 and S1 dot equals S3. And then we also have C, S1 is not equal to S2. Well, that's not true. So it must be B, where S1 has the same, it refers to the same object and also has the same characters as S3. Let's run it. That's true. So the answer was B. Which of the following is true after the code executes? All right, so I have S1, once again, is assigned the value of hi, a new object. S2 is assigned the value of by, and then S3 assigned the value of hi. So S1, is it equal to S2? Are they the same object? No. So I'm going to short circuit out and not even look at the rest of that. S2 dot equals S3. Well, no, because the values are entirely different. By and hi are not the same. S1 is not the same object as S3. That's true. And S1 dot equals has the same characters as S3. That's also true. So the answer here would be C. All right, 377. Which of the following code is true after the code executes? There's a lot of examples like this on not only the AP exam, but as I mentioned, if you ever get your Java certification. Even though I knew Java, my job still required me to get a Java certification when I was working. And it was funny. I had to take this exam and study for it and learn all the different possibilities of what could be on the exam. And the first time I just took it just to take it without studying for it. And I passed it, but I got a score that I wasn't too thrilled about. It's good to always take time to go through and make sure that you're taking your time with it. So let's make sure we go through these problems slowly. S1 is assigned the value hi. S2 is assigned the value by. And then S3 is assigned the value hi again. Okay, so three separate objects. Is S1 the same object as S3? No. So I'm going to short circuit out of that and move to the next one. S2's value is the same as the value in S3. No. So I'm going to short circuit out of that. S1 is the same object as S2, but there's a not. So that's true. And S1 is not the same object as S3. That's, oh, sorry, not the same object. And that is also true. So I'm going to go with that one, C, and that's correct. All right, so the value inside the parentheses was false in both of these cases, but then the exclamation point then turned it to a true because that means not. All right, 373, comparing with null. One common place to use equals equals or not equals with objects is to compare them to null to see if they really exist. Sometimes short circuit evaluation is used to avoid an error if the object doesn't exist. As I just mentioned previously in the past few, I was short circuiting out of that and moving to the next line, and knowing that if this isn't true, there's not point in looking further past there if we're using an and. So remember that short circuit evaluation is used with and in Java, meaning that if the first part of the condition is false, it doesn't have to check the second condition, and it knows the whole and test. It also works with an or. If the first in an or is true, it short circuits out as well. All right. It says try the following code to see a null pointer error. This is a type of error that you would get. It says if you don't see the error because of the auto grading, you can copy it into the pencil icon. Since S is null, index of throws a null pointer error for S. So let's just go ahead and take a look at this, and then we'll read over it. I have a class, I have my main method, I have a string, and it's assigned null. Sometimes we just create strings and variables and assign the value of null just to get it in there as we're programming, and later can be assigned a value. We're going to use this later, but right now it's null. We haven't assigned it a particular value other than null. So it says if S dot index of A, so it's looking for the letter A inside of S, which doesn't exist, right? If it's greater than or equal to 0, which means that's somewhere in the word, system.out.println, that string contains an A. If S is not null and S dot index of A is greater than or equal to 0, it's somewhere, A is somewhere in the world, in the word, it says S contains an A. So if we run this, compiling and running your code now. If we run this, it says since S is null, index of throws a null pointer error for S. Comment out the first if statement and run the program again. So I'll go ahead and just write single line comments here. Could have blocked it out, but okay, so we're comment out the first if. Okay, and it says by commenting out the first if, the second if statement avoids the error with short circuit evaluation because S is not null. Because S not equals null is false because S does equal null. The rest of the Boolean expression is not evaluated. Now change S to set it to apple instead of null. So I'll change it to apple. And I'll go ahead and run it. All right. So it says now change, or we did that in the first line, and run the code again to see that the if statement can print out that apple contains an A. So apple contains an A. Let's go ahead and push this here. And I'll run it one more time, taking out the comment. So that way we're able to go back to our original example. We have two ifs. We have string S assigned the value of apple. If the index of A is greater than or equal to 0, which A is 0, so it's equal to, so it's true, it prints out contains an A. If S is not null, so it's not null, and S dot index of A is greater than or equal to 0, so it's somewhere in there, system.out.println apple contains an A. So that's why it's able to pass. It prints it out twice there. It passes all of these tests, and we're done. All right, another video. Not going to watch it. If you would like to watch it, you're more than welcome to. All right, programming challenge, tracing code 374. It says, what will the following code print out? Trace the code by drawing diagrams of what is going on in memory, like the figures above, and then show the values of S1, S2, S3, S4, and the output after each line of code. Remember that you can use trace tables to track the values of variables as they change throughout a program. To trace through code, write down a variable in each column in a table and keep track of its value throughout the program as you go through it line by line. All right, so I remember doing this last year. I was trying to think, why does this look familiar? I feel like also we've done something similar to this year already. So we're trying to figure out what everything is going to be in the end. So I have string S1 is assigned null. Okay, let's walk through this. S2 is assigned high. S3 assigned high. S4 is by. All right, so 4 objects. It says if S1 equals null, it is, then assign S1 to S2. All right, I wish I could write a comment in right here. So I'll go ahead and just write this down in the meantime. I would like to actually write it on or at the back of here. I'd like to have it up so you can see it. But right now, S1 is assigned. I'll just maybe, yeah, I'll do it down here. I'll keep track. So S1, S2, S3, and S4. I'll do it down here instead of writing it out so you guys can see it. Okay, so S1 is now assigned S2. So S1 now refers to S2, which the value of that is high. Okay, S1, if S1 is the same object as S2, which that is true because we just assigned it in the last example, then print out S1 and S2 refer to the same object. Okay, so I'll go ahead and print that out. S1 and S2, I'll copy it. S1 and S2 refer to the same object. All right. Now, S3 equals S4. Is that true? Is S3 the same object? The answer is no. So it's not going to run this. And then it says if S1 dot equals S2, meaning is the value in S1 the same as S2, which is true. And S2, the value that's in S2 is the same as S3 character by character. S1, S2, and S3 all say high. So that is true. So system.out.println S1, S2, and S3 are equal. So I'm going to go ahead and delete everything else because that's actually what prints out. And I'll save it. And I guess it doesn't even look at it, but that's what should print out. I was waiting for it to actually run it. S1 and S2 refer to the same object in this example here. After in this line right here, we assigned S1 to S2. So that refers to the same object. And then S1, S2, and S3 are equal, meaning they all character by character equal the same thing, which is high. All right. A shorter lesson, 375, that's a summary. It says, often classes have their own equals method, which can be used to determine whether two objects of the class are equivalent. Equivalency, meaning the same characters. Two object references are considered aliases. Alias is just a nickname, it's referring to it. When they both reference the same object. Okay. You know, even though my first name is, well, even though I was called Joshua by my mom, she also calls me Josh, just a nickname, an alias, it still refers to the same person, which is me. Object reference values can be compared using the double equals as well as the not equals, the exclamation point equals, to identify whether or not it's referring to the same object. And the reference value can be compared with null using double equals and not equals to see if the reference actually references the object. Okay, you have attempted 8 out of 8 activities on this page, completed, well done. And that is 3-7 comparing objects.